The next type of story problem that we want to solve is what we call a mixture problem. And the idea behind a mixture problem is that we've got some quantity being stored somewhere of item A, and we've got another quantity of item B that are related to each other. So we could be talking about amounts of mixing coffee types, or we could be mixing nuts and chocolate to make a trail mix, or we could be mixing gasolines to get a different ethanol level or oxygen level or whatever it is that we're looking for. Or we could be mixing interest rates so that we get exactly the amount of money every year that we want. And we're going to take these two and we're going to form a new item, our mix C, by taking some from A and some from B and mixing them together. And so that's visually what we're looking at. And conceptually, what we want to do, so I'm going to give you the model now, and then we'll work through a problem and see how it works in relation to the model. So it helps to have a table that's going to have 3 rows and 3 columns. So here's item A, here's item B, and here's the mix C. And then what we have is we have an amount of some sort. This is how much we're taking from each. So this is pounds if we're talking about coffee or trail mix or oatmeal or whatever type of physical thing we're talking about. This is the principal if we're talking interest. This is the liters if we're talking gasoline or acid. We have a rate, which is a percentage for some types of things, or it's a price per pound for others. What it does is it lets us convert this amount to something that we call the value. How much is this worth to us? And so this is the price, this is the interest, and this is how many liters are the thing that we're interested in. Whether that's gasoline, whether that's ethanol, whether that's acid, how much of what's in the bottle is actually that liquid, rather than the water that it's generally mixed with. And the other interesting thing about this is remember that our rate converts an amount to a value. And so if we have a rate R and we have some amount A, then the value is A times R. Or we could have B T, oops, let's change colors so it stands out, and we get B times T. Or we could have our mix C times some rate U and get the value C times U. So we're always multiplying the first two and setting it equal to the third. Amount times rate gives value. Along with this, we want to recognize that the amounts and the values have to add up. So A plus B will always equal C, and this means that our amounts add. So if we want to mix 10 pounds of M&Ms with 20 pounds of peanuts to create a very simple trail mix, 10 pounds plus 20 pounds equals 30 pounds, and we'll have a mixture of 30 pounds. Likewise, we don't want to lose any value when we're doing this. This is the point in mixture problems. We don't want to sell it for less than it's worth, and we want to be able to get some specific amount out of it. So by the same token, A times R, how much we pay for those peanuts, or those M&Ms, plus how much we'd pay for the peanuts has to be equal to the amount we'd mix times whatever our new rate is. And that's, if it doesn't, then we're losing money or we're cheating somebody out of money, which is not something we want to do. We may, if we're a business, we may mark this up later, but when we're calculating this out, we want it to be even. And so we'd be marking it up so that we could charge it for more to take into account the fact that we created it ourselves. But this is our value equation. And this value equation is where most of the work that we want to do gets done. So let's look at a specific mixture problem. Suppose that Kevin has $15,000 to invest. He got an inheritance from his grandfather, and he has $15,000 now, and he doesn't want to spend that. He wants to save it, but he wants to make sure that he gets an annual rate of return of 9%, or $1,350 annually. His financial advisor recommends that he invest some of the money in corporate bonds that pay 12%, and the rest in government-backed treasury bonds paying 4%. How much should be placed in each investment in order for Kevin to achieve his goal? So again, step one. Did you notice anything important? Our question is, how much should be placed in each investment? And you should know that on a lot of tests that I like to write, rather than asking for both, I'm just going to ask for one. And so the key here is, which one am I asking for? In this question, we're going to answer both. On the test, we need to make sure we answer the right one. If we answer the wrong one, we're going to lose some points because we didn't read the question carefully enough. We're also going to identify things that we know. We know that we have 15,000 total. And we want 9% or $1,350 back in value. Finally, we know that 12% and 4% are the corporate bonds and the treasury bonds individual payouts. And something that I didn't specify earlier, but I should have, notice as well the difference. The 9%, which is our total, is between the 12% and the 4%, which are our items being mixed. In order for the rates to work, the mixture rate has to be between the other two. If it's more, you can't get it. If it's less, you can't get it. It has to be between them. So step 2 is to name our unknowns. And we're going to look at our unknowns. I'm going to use C for corporate bond. And I'm going to use T for treasury bond. Make it real easy at the end of the problem to make sure I'm answering both of these correctly. And it's time to create our model now. So what we're going to come up with is a table. So let's see, we can see the whole thing here. That's going to have all the information we can get on it. And we're going to start by grabbing those pieces that we know. And so this is the corporate bond, this is the treasury bond, and this is our mix. This is what he wants out of it. This is the principal, this is the interest, and this is our interest rate. Notice we're talking about annual rate of return, so we're not going to use a T. We're going to assume that's a 1 and that it doesn't factor into what we're doing. So the question is, where do we put the $15,000? It goes in the principal under the mixture, because that's how much total we have to invest. And in Chapter 1, we're going to do this a little bit differently. We'll come back to mixture problems again in Chapter 3, but we're going to pick one of these, and we're going to let the corporate bonds be this one, and the treasury bonds is going to be 15,000 minus C. I want you to think about this for a minute. Why would it be 15,000 minus C? The reason is that if I put 5,000 to corporate bonds, then I take that 5,000 from 15,000, that means the treasury bonds is 10,000. And the reason we're doing this now is so that we only have the C's floating around. Now we can put in our interest rates. Our interest rates are 12% for the corporate bonds, 4% for the treasury bonds, and 9% for the mix. Now our last column is the interest, which we get by multiplying across. 0.12C, 0.04 times, notice the quantity, 15,000 minus C, And the mixture is, we're already told, but we can get a calculator and check it. This comes out to $13.50. So here's my model. Here's step 3. But we're not done with it yet, because we don't have anything to solve. So we need to go from step 3, before we can get to step 4, we need to go from our table that we've used to put everything in and figure out what belongs where, and we need to grab our equation from it. We're going to grab our equation from our value, which is our interest. And so we're going to take the corporate bonds, add it to the interest from the treasury bonds, and set that equal to $13.50. And this will tell us how much we should have gotten. Step 4 now comes in and says solve. So we're going to start by distributing. We're going to grab a calculator for this. We're going to do 0.04 times 15 is 600. Minus 0.04c equals 1350. We'll combine like terms. We get 0.08c plus 600 equals 1350. We will subtract 600 from both sides, so that 0.08c equals 750. Divide both sides by 0.08. Get our calculator out again. And our corporate bonds turn out to be $9,375. So we're going to take $9,375 of our $15,000, and we're going to invest that into 12% corporate bonds. Now that we know C, we know that T, remembers this right here, is 15,000 minus C. So T is 15,000 minus 9,375. And that's going to give us 5,625. So I now know C and T. That's step 4. Step 5, we need to make sure that two things are true. We need to check, is 5625 plus 9375 equal to 15,000? Did I invest all of my money? And this should come out right. And it does. But we also need to check, is 12 times 9375, 12%, plus 4% of 5625, does that actually equal 1350? So 0.12 times 9375 plus 0.04 times 5625 equals 1350. Sure enough, if I invest my money this way, both sides check out. I invested all my money like I wanted to, and I'm guaranteed to get $13.50 back. So we've checked our answer. Now the last thing that we need to do is just come back and say that our corporate bonds will be $9,375, and our treasury bonds will be $56.25. And we've answered the question.